So that is November 2019 question 1B. And is a question on sensitivity analysis, how sensitive, how reactive NPV is to a given change in a decision variable. And remember we said we use the concept of sensitivity ratio when evaluating projects under, in this case. So November 2019 question 1B, let's look at it. You're told that Sunny Technologies Limited is considering investing 50 million in a new machine to manufacture computer microchips with an expected useful life of 5 years and no salvage value. So initial outlay 50 million, miaka ni tano, salvage value ni 0. It is expected that 20 million units of microchips will be sold each year at 3 shillings per unit. Each year, that makes it annuity. So each year there is an annuity. For 5 years, of course, variable production costs are expected to be 1.65 per unit, while incremental fixed costs will be 10 million per annum. Per annum, again, it's annuity annually. Cost of capital is 12%. Evaluate the sensitivity of the project's NPV to the following changes. Sales volume. Now, under sensitivity analysis, I remember we said that we use the sensitivity ratio to evaluate the effect of NPV to a change in a decision variable. Like in our case, we know that the sensitivity ratio, you can remember the formula, it was equals to NPV of project divided by present value of decision variable. So from the formula, we appreciate that we must get the NPV. From the formula, we appreciate that we must get the NPV so that we have the present value of the decision variable. In getting our NPV, we need our initial outlay. And initial outlay, it was to invest in a machine, considering investing 50 million in new machine. So initial outlay in millions of shillings. I can see it's 50 million. We did not invest in any working capital. We did not invest in any working capital. We don't have any salvage, we don't have any incidental costs. So that is our initial outlay. Then you look at annual net cash flows, just the normal way. And for annual net cash flows, you can have the year. And we know it is year 1 to 5. Year 1 to 5. And we can do 1 to 5. The figures are in millions of shillings. So you have each year we are going to produce and sell 20 million units of microchips being sold at 3 million each. So I can actually start with annual contribution. Annual contribution. So our contribution margin, we have selling price per unit is 3. Variable cost per unit is 1.65. And we are going to sell 20 million units.
Hello,
Hi.
teacher.
Yes.
Teacher,
Yes.
enlarge enlarge what you are writing. I cannot see. Enlarge them a bit.
Hazionekani.
Eh,
That's better.
yeah.
Great. Sawa. Now we have the selling price per unit is 3 shillings. Variable cost per unit is 1.65. We are selling 20 million units annually. So therefore, so kila mwaka, our annual contribution is 27 million. Do you have the fixed costs? Annual fixed costs. Wametuambia incremental fixed cost will be 10 million per annum. So you have 10 million kila mwaka. So that gives us our annual pre-tax cash flows. Which is 27 minus 10. Sorry. Which is simply 17. Great. Now, at that point, we don't have the tax rate. Na kama hatuna tax rate, then hatuna depreciation. That's an examiner that is wishing us success. If there is no tax rate, there is also no depreciation. So in such a scenario, you don't guess. In finance, you don't guess tax rates. So what does that mean? That our cash flows remain at that point. So that is our annual net cash flows. We don't have any depreciation. We don't have any depreciation, and for that reason, we don't have tax, sorry. And if we don't have no tax meaning it's zero, even the depreciation tax should be the tax depreciation times 0, which will be 0. So net cash flows zinabaki hapo. I didn't see any terminal cash flow in this question. Haiko, ingekuwa tungeiweka. So can we have our NPV at 12%? So NPV at 12%. I can see we are having 17 million times, should be PV. Our R is what? Our R is 12%, and our N is 5 years. Minus the initial outlay. Initial outlay is 50 million. Can you have this 12%? 5 years is how much?
Table 2.
Of course, it's table 2.
12%.
I think 3.60.
3.48.
3.6048 minus the
Yeah.
initial outlay of 50. So that is our NPV. That's the first step. Now that being our first step, we are just guided by what are we looking for?
Evaluate the sensitivity of project.
Yes, we are evaluating the sensitivity of the project, and in evaluating the sensitivity of the project tukasema kuwa we use the sensitivity ratio, which is the NPV of the project divided by the present value of the decision variable. Now we have the NPV. Now we need to look for the present value of each of the decision variables. So we start with number one. Number one, we are looking at the sales volume. Sales volume. And for the sales volume, we appreciate kuwa the sensitivity ratio shall be equals to NPV of the project we divide it by present value of sales volume. NPV of the project divided by the present value of the sales volume. As simple as that. Our sales volume, the quantity per annum is 20 million. 20 million is an annuity, so we discount using the annuity. So our NPV is 11.26.2816. We divide that by sales volume ni 20 million. We multiply by we discount at 12% for 5 years. Remember, the sales volume is 20 million annually, 20 million units. It's the volume, not the value. 20 million annually, so that makes it an annuity. We discount using 3.6048. Fanya hii hesabu tunapata ngapi? Of course, we multiply by 100.
Why 100? Are we giving it on a percentage?
Yes.
$15.6.
50.
Is that 15?
15.6.
0.64.
So 15.64, that becomes the sensitivity of that, of the sales volume. That is our 3 marks. The number 2, we have the sales price. Just the same concept. So sales price, we know that our sensitivity ratio would be equals to NPV of the project divided by the present value of the sales price. Now this is the value of sales. So that is that one divided by the sales price. Price per unit is 3 times 20 million. Then we discount times 3.6048. So even the sales are coming in annually. We're going to have sales of 20 times 3, that is 60 million annually for 5 years. So it's an annuity. So what percent is that?
$5.2.
How much?
5.2.
5.2.
5.2%.
0.22.
5.22. Thank you. Then, of course, the third one, they want us to get the sensitivity of the variable cost. So variable cost, we know that sensitivity ratio equals, so you have NPV of the project divided by the present value of variable costs. So our NPV is here, divided by the present value of variable costs. Our variable cost per unit is 1.65. So this is 1.65 annually again. Annually, that is an annuity for 5 years. So if you use the calculator, what is our sensitivity ratio there?
So 9.48.
9.48. Thank you. So that is the 9 marks. NPV of the project divided by the present value of the decision variable. So it depends what decision variable are we considering. In our case, we have the sales volume, sales price, variable cost. If they had asked us of the sensitivity of the initial outlay, the concept will still be the same. So the initial outlay we have probably just trying to be a little bit creative. If they wanted us to get the sensitivity of the initial outlay, we know that the same concept, sensitivity ratio would be equals to NPV, of course, NPV of the project divided by the present value of the initial outlay. Great. So in our case, our NPV is 11.218. Then you divide by the present value. Initial outlay in our case was 50 million. And 50, so you divide by 50. And when you look at the 50 million, you cannot discount the 50 million. It's already in its present value terms. That's why in initial IO, discount PVIF ya IO inakuanga 1 because the figure is already in its present value terms. So this would simply be that divided by the 50. That one you cannot discount. So times 100 to make it a percentage. That is 9.1%. It's just NPV over the present value of the decision variable. Great. Hope that is okay. Now, when you look at part C, they want us to use the scenario analysis. So can you write something on scenario analysis before you answer this question? Scenario analysis, that should be our number 3 or number 4?
Number 3.
Number 3, thank you. So scenario analysis. Let me say, it is similar to sensitivity analysis. It is similar to sensitivity analysis. Except that under scenario analysis, more than one variable, more than one decision variable, more than one decision variable may be considered at a time. More than one decision variable may be considered at a time. Full stop, then you say, there are three types of scenarios. There are three types of scenarios, i.e. best case scenario representing the most likely outcome of a project. So best case scenario representing the most likely outcome of a project. We have number 2. Best case scenario. Best case scenario representing best case scenario representing the most optimistic. Best case scenario representing the most optimistic outcome of a project. So we have the best case, we have the best case, and we have worst case. Ama worst inakubalika yote. Worst case scenario representing the most pessimistic outcome of a project. Presenting the most pessimistic outcome of a project. Great. Next, skip one line, then you say, we compare the percentage change in NPV. We compare the percentage change in NPV from the best to the best case, from the best to the best case, with the percentage change from the best to the worst case then you say if the change from the best to the best, if the change from the best to the best, hii ya kwanza, if the change from the best to the best.
Teacher,
Yes.
is this the change from
Ile statement yetu ya kwanza hii matamshi balaa. If the change from the best to the best, hii ya kwanza, if the change from the best to the best is more than yeah. So if the change from the best to the best is greater than from the best to the worst, the project is viable, and vice versa. And vice versa. So let's look at November 2019 question 1C. Now we are told that further analysis of the company in B above suggests that sales volumes could depend on expected economic state as follows. So you can have economic state, poor, normal, and good, annual sales volume with the probabilities. They want us to get the expected NPV of the project using scenario analysis. They just want us to get the expected NPV. And we know that expected NPV equals to the summation
NP
of NPV times what?
probability.
Times the probability. So can we have the three NPVs? So NPV under poor condition. Cash flows, can we say annual net cash flows 3 shillings minus 1.65 close the brackets times 17.5 then we multiply by the annuity factor. Annuity factor was 3.6048. 3.6048. Then we subtract the initial outlay. Initial outlay was 50. That will give us the NPV, right?
Yes.
I'm lost.
Where are you lost, Julie?
Okay. We have been given probability and annual sales volume.
Yes.
We're getting the NPV, yeah?
Yeah, we're getting NPV under each state. Under each state of probability. So NPV hiyo ni under the poor state. Tumepata NPV yake ndio hiyo.
That is 3.2. Hiyo ya kwanza umetoa wapi?
The selling price per unit is 3 shillings. The variable cost is 1.5. Oh, we didn't less the fixed costs. Wow.
Yeah.
Hapa tunafaa less fixed costs. Minus fixed cost
Yeah.
of 10. Great. So minus 10. Is that right?
Yes.
Kama imetunyorosha utuambie kwa calculator yako.
3 minus 1.65 minus 10.
Inakaa uongo.
Kabisa. Please don't lie to us.
Just confirm.
That is 3 minus variable cost of 1.65 minus 10.
Calculator inasema nini? Oye.
You multiply by 17,500.
Inasema hiyo.
Inasema hiyo. Thank you.
3.60.
So under the normal, the only thing that is changing is the quantity. And actually ya normal tulikuwa tushapata, hata hakuna haja ya kurudia. Ukirudia, you'll still get the same amount. Because ya normal ni ile tulikuwa nayo hapa juu. The quantity is 20 million. 20 million ndio ilitusaidia hapa juu tukapata NPV yetu. under 20. You can remember. So I was saying that for the normal ni sawa na ile swali ya juu ya part B, because everything the quantity is 20 million. Sasa tukirudia ukiandika ni sawa, but we expect to get the same answer. Under normal circumstances, you can avoid doing that one. Then we have the last one, which is under good condition. So under that, we have our quantity is now 22.5. So times 22.5. So this is 22.5. So tuko na hizo NPVs tatu. So this is under good. And of course tuko na probabilities zake. So we have the NPV and we have the probability. NPV acha nikopi tu hizi zote. So tuko na NPV ya poor, normal and good. Sorry for that. Tuko hapo. Ika hivyo. So probability ya poor ni 0.3. Probability ya normal ni 0.6. Na probability ya good ni 0.1.
Excuse.
Yes.
Hiyo probability ya poor ni
0.3. Kwa hapa kwa swali.
0.3. Hapa hivi. See probability the NPV. Expected NV it is negative
0.8846.
8846.
Yes.
Okay, I will do it. I'm getting a different one, but I'll do it after this.
Okay.
Nimekosea.
Haupati yetu?
Nitarudia tena.
Sawa. So you have it there. So can you get the expected NPV? So this times this, plus this times this, plus this times that, and we get our expected NPV. 0.8846 times 0.3 plus, so equals to this times this plus this times this plus this times this. 8.84, 8.85 million. So that is our 5 marks, unless there's a question. Kwa sawa, si ndio? Now, let's take, I think a similar question is in September 2019, September 2015, pilot paper. Should be the second last sitting. September 2015. Just go there, check which specific question it was. September 2015, question 4. September 2015, question 4. Allow me to go to tuisome pamoja tuki-explain alafu utafanya kazi yako. Now, Omena Limited is a firm in the manufacturing industry. The management of this company are considering purchasing a new machine at a cost of 125 million. So 125 million is the initial outlay. This investment is expected to reduce manufacturing costs by 45 million annually. When you reduce costs to increase profits. So that's like our annual contribution. Decrease in costs.
Excuse, that is question number?
Question number 4 of September 2015.
2015.
Yes.
Question?
Question number 4.
Okay, I'm there.
Okay.
Hmm.
So, considering purchasing a new machine at a cost of 125 million, it is expected to reduce manufacturing cost by 45 million. When costs reduced by 45 million, profits increases by the same amount. The firm will need to increase its net operating working capital by 12.5 million when the machine is installed. So that forms part of the initial outlay. But the required operating working capital will return to the original level when the machine is sold after 5 years. The initial outlay cost of the machine, incidental costs sijaziona, but we have the investment in working capital, which forms part of the initial outlay. And of course, as a terminal cash flow, we shall recover the working capital after 5 years. Omena will use the straight line method to depreciate the machine, and it expects to sell the machine at the end of 5 years operating life for 11.5 million. That's the salvage value. Tax is 30%, cost of capital is 10%. They want us to get the project's NPV. I think NPV we can all get from there. Then we are told the firm's management are unsure about the annual savings in operating costs that will occur with the new machine's acquisition. Management believes that these savings may deviate from their best case value of 45 million by as much as a plus or minus 10%. So hizi savings za 45 million, hapo wanasema kuwa the firm, the management estimates that they may increase by 10% or they may reduce by 10%. Deviate from the best case, which is 45, by as much as a plus or minus 10%. So either increase by 10% or reduce by 10%. Determine the NPV of the project under both situations and comment on the sensitivity of this variable. So it's the same case. So you compare the two scenarios. When you increase the NPV when you increase the savings of 45 by 10%, what will be the NPV? When you reduce it by 10%, what will be the NPV? Now, commenting on the sensitivity is actually looking at the percentage change. So tafuta NPV ukiincrease hii na 10% na utafute NPV ukireduce hii na 10%. Then hapa part A utakuwa ushapata NPV. So sensitivity, remember, is how NPV is affected by a change in a decision variable. So currently tuko na NPV ya part A. Ukiincrease na 10%, NPV ita change by what percent? So you have the so you'll have to look for the percentage change in NPV, which is simply the new NPV minus old NPV divided by the old NPV. New minus old over old. And of course, you'll multiply by 100 to make it a percentage. The new NPV ni ile yenye umepata after the change. Old NPV ni ile ya part A. You can compare the two scenarios. The scenario is, option ya kwanza is plus 10%. Na option ya pili inakuwa minus 10%. Ukiongeza na 10%, what will be the percentage change in NPV? Ukireduce na 10%, what will be the percentage change in NPV? I expect the same answers to be the same because the change is at this is by the same amount. That's why you are not asked to advise. Sasa, I repeat, the old NPV ni ile NPV ya part A. The new NPV zitakuwa mbili. Kuna NPV ya kwanza ukiincrease na 10% na kuna NPV new ya pili ukireduce na 10%. So kama umeincrease na 10%, what is the change in NPV? New NPV ile ya plus 10% minus the old NPV ya part A divided by the old. What if you reduce by 10%? You'll have the new NPV minus the old NPV of part A divided by the old. If you are true, that will be the sensitivity. So comment to just make a statement of your answer. NPV changes by this percentage. Now, if we're okay up to that point, allow me to explain part C. We go through part C to analyze, to understand. Suppose the firm CA4 suggests that the firm does a scenario analysis for this project because of the concerns raised about data assumptions, particularly the annual operating cost saving, the salvage value, and the net operating working capital requirement. After an extensive analysis, she arrives with the following probabilities and values for the scenario analysis. Remember tulisema kuwa scenario analysis is the same as sensitivity analysis, except that scenario may have more than one decision variable changing. That is the case here. Worst case, best case, and best case. Annual operating cost savings will be 36 million, 45 and 54. Salvage value, net operating working capital ziko hapo. You're required to determine the project's expected NPV, standard deviation, and coefficient of variation. Now, ili upate expected NPV, lazima upate NPV equals the summation of NPV times probability. So we need, hizi ni kama kusema tuko na projects tatu. Hii ni project ya kwanza, hii ni project ya pili, hii ni project ya tatu. All other factors remain constant. So you can have three options here where you have the worst case. You can have here the worst case. You have the best case and you have the best case. Hata ile option ya 2 unaweza kill two birds with one stone, unaweka hapa plus 10% na minus 10%. Unatafuta initial outlay, annual net cash flows, terminal cash flows, unapata NPV. So now, just to help you, ukiangalia best case, operating cost saving is 45 million. Salvage value ni 11.5 million. Working capital ni 12.5 million. Ukiangalia kwa part A of the question, salvage value is 11.5 million. Cost savings 45 million. Working capital ni 12.5 million. What am I saying here? Answer part A is the same as the answer of best case. So you don't need to repeat it again. Ushaifanya kwa part A, uko na answer yako. So you only bring here the NPV under best case, which you'll have gotten in part A. Worst case, you have to get the initial outlay, annual net cash flows, terminal cash flows. Best case, the same.